Assalamualaikum warahmatullahi wabarakatuh. Alhamdulillahilladzi hadana li hada wa ma kunna linahtadiya laula an hadanallah. Asyhadu an la ilaha illallah wa asyhadu anna Muhammadan abduhu wa rasuluh. Allahumma shalli ala Muhammad wa ala alihi wa ashabihi wa man tabi'ahu bi ihsan ila yaumiddin, amma ba'du. Okay, student, meet you again. Today we study about the CPM and PERT. CPM and PERT, that is the project network. Yeah. After we discuss about WBS, we break down our activity from our project. We have the project and break down our project into several activity in several scope. After that, we need the network. To this, we study about the CPM, critical path method, and PERT, program evaluation and review technique. That is the technique to evaluate the network. Firstly, we have to study about the project. We review the project. What is the project? We know that the project is a specific objective, a unique endeavor with multiple activities, and then precision relationship. Yeah, we define the precision relationship, specific time and period for completion. That is the special term in the project. Yeah, the activity, and then special goal, or objective, and then we have precision relationship. Yeah. We have the precision relationship from any activity to any activity, and then we have the specific time here to complete it. So we have the activity, specific goal, and time to complete this activity. Like this, yeah. We have, this is the time, and this is the activity. Okay. Plan your work first, then work your plan. That is we have unique one-time operation design to complete a specific set of the project. That is the definition of a project. How we analyze our project management and the network analysis. One definition of project, that is temporary endeavor undertaken to create a unique product or service, In project management is scientific way of planning, implementing, monitoring, and controlling the various aspects of the project, such as time, money, and then material and man and other resources that we have of the organization, I think. So from this, we have to make analysis of network. In general name, given the certain specific technique, it can be used for planning, management, and control of the project. Yeah. So we have to analyze the network. Okay, talking about the project management, how is it different? We know that in the project management, in the project, we have limited time frame. You know this, we have limited time frame, and we have to focus to specific objective and we have to less bureaucratic. Why should it use? This project is for special need, I think. Special for new or improve product and service. Yeah. We have the product and service. To improve this, we need another project. Yeah. Any project. What are the key metrics here in this project analysis or in project management? We have 3 key metrics here: the time, cost, and then the performance of objective or achievement, I think. So we need this: time, cost, and performance objective. And we have to define the key success factor for top-down commitment, having a capable project manager, having time to plan, careful tracking and control, and then make good communication. Okay, to success the performance objective, we have to make a planning network, and to use the method, we have 2 methods here: the CPM, critical path method, and then the program evaluation and review technique. That is the 2 methods to network analysis. In network planning, we have the activity, and every activity we connected predecessor, and after this we have activity A, and then after that we do B, after that we do C. That is the predecessor or prediction. That is the predecessor, and then this activity next, and then this next. So this called as the network. That's called as the network. And we analyze this network using 2 methods. The critical path method, we find the critical path and we analyze the network and we find the critical path. So the critical path, that is the interesting path in the network. Or we use the program evaluation and review technique. In this, we use the statistic about the duration of every activity from the statistic. So this is the method to analysis. This method to analysis the network planning. To managing a project with the network planning, we have 4 steps. Firstly, you have to describe the project. Describing the project. You have to describe the project. After that, make the diagram of the network. From describe the project, use the WBS from this. Use the WBS. From this, you have the activity to success your project. From this activity, you make the network by diagrams or diagramming the network. After that, you estimating the time to completing every activity or the completing our project, and then you have to monitor the progress of the project. That is the use of network planning. You have to know about 2 methods, the CPM and PERT. In history, this method come from the DuPont chemical plants. CPM was developed by DuPont, and emphasis was the trade-off between the cost of the project and the software completion time. So in this program, this method, we evaluate the cost and the time to completing the project. Again, for certain activities, it may be possible to decrease the completing time by spending more money. how does this affect the overall completion time of the project. And then the second method, that is the PERT. The PERT was developed by the US Navy for the planning and control the Polaris missile program, and the emphasis was the completing the program in shortest possible time. In addition, PERT had the ability to cope with a certain activity completion time. For particular activity, most likely completion time for weeks, but it could be anywhere between 3 and 8 weeks. You know this. We have 3 and 8 weeks. Most likely is 4 weeks, but in audit could anywhere between 3 and week. So we have to estimate from this time. The optimistic is 3 weeks, and the pessimist is 8 weeks. And we have the most likely, that the most likely is 4 weeks. Most likely is 4 weeks. That is the fundamental of PERT. And the fundamental of the CPM is to find the critical, the part. Because when we're completing time by spending more time, how does this affect to overall? We decrease we certain the activities it may be possible to decrease. Here we have many activities, and we study what activity can decrease. From this will affect it to overall completing time of the project. So in this method, we have to find the critical part from the network. In this, we study about the most likely, weak, and optimist and pessimist, and use the activity completion time to find the most likely. We study in detail about the CPM or critical path method. Here we have the definition. In CPM, activities are shown as the network or present relationship using activity or node network construction. We have like this: the activity A, and then the activity B. This activity, I can say this. We have like this. We have 1 and 2 and 3 like this. We start here. That is the activity, and we have the activity A, and we have the activity B like this. The activity A, that is predicted by the activity B, or the activity B predicted by the activity A. So we study about the relationship and every activity. In this context, the single estimate of the every time, and then we deterministic activity time. Is that the sequence enough of activity, and even where there is no slack or zero slack? Longest path talk a network. This is the critical path. We identify the longest path talk a network. That is the critical path. And then the minimum project completion time. This method used in production management for the job of repetitive in nature, when the activity time estimate can be predicted with considerable certainty due to the existence of the past experience. So this method, the critical path method, used in the product management, because we have the repetitive in nature activity, we have activity that is repetitive in nature. So for operation, this is good. The critical path method for operation planning in the organization, because we have the activity that repetitive in nature, like our lecture maybe. Okay. How we can do in CPM? We have the steps here. Steps in CPM. Firstly, you have to specify the individual activities from your project. After that, determine the sequence of the activity. I will give you example. Maybe we will see the example. We have the project. Firstly, you have the project, and using the WBS, you will identify the many activity here. Many activity, and you have activity A, B, C, like this, and every activity you will analysis or determine the sequence of the activity. What is the sequence of activity? We have to make a question. Can we do the activity B before activity A? If we cannot do the activity B before activity A, so the sequence is A, and after that we can do B. Can we do this activity of C like this, and we have C activity? Can we do this before activity B or activity A? When we can do this before activity B, but we have to do this after activity A, we can see that the B from A, we can do the activity C without sequence from B to C. So we have to determine the sequence of every activity like this. So from this activity, from the second step, after we determine the sequence of the activities, then we draw the network diagram like this. Yeah, we have this A, and then B. From this we have C like this. This diagram, we draw this as the diagram, and from this we estimate the activity completion time. The activity completing time from A to C, and from this we have to identify the critical path. Where is the critical path? And then update the CPM diagram. Okay, so the interesting step here, that is to find the critical path. That is the longest step. Yeah? You know this, the longest path the longest path through a network, that is the critical path. So we find the critical path by estimate the time, and the longest time through the network, that is the critical path. Okay, before starting any of the techniques, the question asked would be, firstly, we have the what activities must be finished before this activity can start. So this question to identify the sequential of the activity to another activity. If this activity can start after or must be finished from before activities, that means activities predecessor, that means this sequence activity, not parallel activity. So we have like this, we have this node, and the second 3 and 4 and 5 like this. Maybe we have this network like this network, this activity B, and then this activity C. That means the activity C can start. Activity C can start. Or activity P, this activity B can start when the activity A has been finished. When the activity A has been finished, we can start the activity B. So the activity B and the activity A, that is the sequence here. But in another side, we have the C here, activity C, and the activity C. We can start activity C without finishing the activity A. So the activity C and the activity A, that is the parallel, not sequence, in this parallel. And from this, we can answer this question: how many times to completing this all activity? Like this, maybe we have like this, 6, like this. How many times to completing this all activities? To completing this, how many times? So we can, you can answer this question. Could be completing this project in 30 weeks? Could be completing this project in 2 weeks? That is the question. That means we have to analyze this activity, all of this activity, and the duration of all of the activity. One answer could be, if we first do activity 1, then activity 2, then activity 3, then activity next, and then activity 10, and then activity 11, and the project would be take the sum of the activity completion time 30 weeks. We can sum of every activity, where when the activity is sequence, what is the minimum possible time in which we can complete this project? That is the question. The minimum possible time in which we can complete this project. So we analyze the network. We can answer this question, answer this question, answer this question, answer this question. All these questions can be, we can answer this using the network analysis and use the method of the CPM. Okay, from this step that I described you before, look at this example. That is the deterministic time estimate. We will determine what time estimate this all activity. Like this, we have 6 nodes here, and this activity locate facilities from node 1 to node 2. We need the duration in 8 weeks, and from the node 2 to node 4, we have the order furniture, and the duration for this activity is 6 weeks. And then in another part, we have that the activity is interview, and the duration from this activity is 4 weeks. And then we hire and train, and for this activity is 9 weeks. And then we have remodel here, and then furniture setup, and then move in. So this is the activity, and this is the duration in every activity, duration here. So we have the question: how many time to complete this project, all this activity? We can analyze this network. That the order furniture, we can do order furniture when the locate facility must be done. After this, we can order furniture. But we can remodel side by side to this activity. Order furniture, and then furniture setup. After that, we can move in. In this part, we have the interview, hire and train, and then move in. So we have the path of the network here. This is the path 1, and that is the path 2, and we have this path 3. So we have 3 paths here, 3 paths from this network. And how many times from the path 1? You can see in the path 1, this activity need 8 weeks. So we can analyze the path 1 like this. We analyze the path 1. We have activity locate furniture, and we need 8 weeks here. After that, we can do the order furniture, and we need the 6 weeks here. After that, we can do the furniture setup, that we need 3 weeks here. And after that, we can move in, and we need 1 week. So the all time from this part, we have 14, 17, and 18 weeks. This time to completing from the part 1. And the second part, we have the part 2 here. The part 2, the activity in the part 2 is the locate furniture, 8 week, and then the order furniture, the 6 week, and then we do not do this order furniture, because in the part 2 we just from locate facility we can remodel that's 11 week like this, and then move in is this activity, that is 1 week. So for the part 2, that is the part 2, we have this part 2, activity locate facility, remodel, and then move in. From the 3 activities, we need 8 weeks and then 11 weeks, so we have 19 weeks. And then move in, we need 1 week, so the completing time is 20 weeks like this. So part 1 we need 8 weeks, and the second part we need 20 weeks. And we have to analyze the 3 parts here: interview, after that hire and train, and then move in. From these 3 activities, we have 4 weeks, sum to for this 4 weeks plus to 9 weeks, so we have 13, and then plus 1 week. So for the part 3, we need 14 weeks. For the part 3, we need 14 weeks. Part 3, we need 14 weeks. So from this analysis, we have 3 parts, and this is the longest part. It's just 3 activities, but the time is longest. And the part 1 have 4 activities, but the time is not longest. It's just 18 weeks. And this we need 20 weeks. So this is the critical part. So we can complete this all activity referring to this activity 20 weeks. We can finish all this activity depends on this part 20 weeks. That is the critical part method. Okay, that is the analysis. I give you analysis before, but here this answer of the question. And this, that I analyzed that the second part that is the longest. So we call this as the critical path. So the critical path takes 20 weeks for the completion of the project. So all the project completing in 20 weeks. How about the slack time? That is the slack time. Why we call this slack time? Why we call this slack time? Because from this network, you know that from the activity 1, from the node 1 to the node 5, you have here people work in this activity need 13 weeks. People work in this activity need 8, 14, and then 17. 13, 17, and then the people that work this activity 19. So when the people do this activity or this sequence of activities network will finish their activity but cannot move in because wait this activity because this is not finished. After this we can to move in if all this activity done, but this activity done for 17 weeks, this activity done for 13 weeks, and this activity will done for 19 weeks. So we have the slack time here. 17 have 2 weeks waiting this activity is finished. So that is the slack time. When you do in this network, you finish for 13 weeks. 4 plus 9, so you need the 13 weeks. But you cannot move in before this activity finish. Okay, 13 weeks and then 4 weeks again. In 17 weeks, this activity or this part will finish. Okay, this part finish, and you cannot move in because this part still progress, not finish. So you have to wait this part to finish, and that means is the slack time. You can see this. The slack time is 20 minus the 18, and the slack time is 20 minus the 14, because this is the longest. This is this part to finish all activity, this part to finish all activity, this part to finish all activity. So the different time of this all finish, that means it's slack time. So we have make the analysis to minimize the slack time, because the slack time is inefficiency. I think this is inefficiency. So this activity must be faster. So the slack time will be reduced. When we can pass this activity and pass this activity in the like this, maybe we can pass in 16, and we can pass this 16, not 18, not 20. So the slack time is 0, and then the slack time is 2. So this is inefficiency. The slack time, that means is an efficiency, because people have to check. People just waiting another activity have been finished. Another activity finished, waiting for another activity to finish. So that is inefficiency in the job, in the network planning. Yeah? In the network, I think that is inefficiency term. Okay, next. From the diagram, you have this term here, that the path, what is the path? Path is sequence of activities that lead from the starting node to the finishing node. This is the path. Starting node 1 and the finishing node is like this, yeah. That is the starting node. This starting node, that is the node 3. 1, 2, 3, 1, 2, 3, 4, and 6. That is the node, and this is the activity. This is the time estimate. So the path is from the node, starting node, and then the finish node here. So that is the path from start to finish. That is the path from start to finish, and that is the path from start to finish. So we have 3 paths here. The path, and then the critical path is the longest path. Determine expected project duration. Maybe this is determine expected project duration because the longest path. All activity will done when the longest part is done. So then the critical activities, that is the activities on the critical path. So we call the critical activities is, in this system or in this diagram, we call the critical activities is locate, facility, and then remodel, and then moving. That is the critical activity. That is the activity that are the other activity in the critical path. We call this as the critical activity. And then the slack time. Slack is allowable slippage for path, the different length of path and the length of the critical path. So the slack time is the different length of the activity by the critical. That is the length, the slack time. So you can find this 2 week here come from 20 minus 18. You can find the 6 week is from 20 minus 14. So that is the slack time because this is the critical. Okay, the second method of the network analysis is the project evaluation and review technique. In this method, we have definition. In PERT, the activities are shown as the network precision of precision relationship using activity on arrow network construction. Because in this activity, we have multiple time estimates. From the critical part, we just have one time estimate. But in this method, we have multiple time estimates and probabilistic activity times. This method we use in project management for non-repetitive job because we do not exact the estimate time for every activity, just probabilistic, because this is not repetitive activity. So in critical path method, we use this for production management because we have the repetitive activity. So we can estimate exactly. We need 8 weeks because this is the repetitive activity. We always do this activity. But in this method, the PERT, this method used for project management. For project management, you know that for non-repetitive job, we always research and development work, where the time and cost estimate tend to be quite uncertain. This technique uses probabilistic time estimates. What does it mean about probabilistic time estimates? The probabilistic time estimate is we separate to three probabilistic time: optimistic time, pessimistic time, and then the most likely time. Optimist, pessimist, and mostly like. We have 3 times for every activities. The time required under optimal condition. When the condition is optimal, we can completing this activity. That mean is the optimistic time. And then when the condition is not good or worse condition, under worst condition, so we can use this estimation, that is the pessimistic time. And then most probable lying of the time, what will be required, this most probable, that means the most likely time. So in this method, for every activity we have optimist time, pessimist time, and mostly time for every activity. So this is different from before method. From before method, in CPM we have one activity and one estimate time. In this we have one activity and 3 estimate time: optimist, pessimist, and most likely. Okay, that is the example of the PRT. This example, that is the note like this. Maybe we do not use the note here. In PRT, so as the network precision relationship using activity on arrow network construction. Like this, we have this activity 1, 2, and 3. But every activity we have 3 times here. This pessimist, 1 is pessimist, 3 is most likely, and the 4 is pessimistic time. So every activity, this activity A, B, C. In this activity A, we can finish as fast as one time here. And then this estimation, we can calculate the expected time using the average time, and we use the most likely time. So the most likely time, when you have like this analysis, time estimate is time optimist, and then for time mostly, and then for time pessimist, divided by the 6. Does it mean like this? This is 1, 4, and 1. So this is the 6. 6 divided by the 6, that means 1. But this formula mean we operate this activity, or we estimate this activity 10 to the most likely time. Before we time for more likely time. When we do not use 2 T optimist plus 2 time optimist, time mostly, and 2 time pessimist, and divide by the 6. That means average, not 10 to the 4 mostly. So this average, just average. Okay, that's different. This formula is different. This formula is different to the before. Okay, we can compare the CPM versus the PERT. We can compare the two methods of CPM versus PERT. We know that from the basis, the PERT work with the probabilistic time, or we cannot ensure the time to completing any activity. So we have optimist, most likely, and then pessimist time. In CPM, critical path method, we work with the fixed deterministic time. How we can fix deterministic time? Because this activity is repetitive. This activity is repetitive. This activity is not repetitive, so we cannot estimate exactly the deterministic time. So we call this as probabilistic time. And probabilistic time, we have pessimist, optimist, and most likely, like this. That is the difference. And then the meaning. The PERT is technique used to manage the uncertain task of a project. Uncertain task of the project. We can use, when you have a project and you know that the activity in this project, you uncertain task, you do not know exactly time to finish the project, just use this tool, PERT. And the CPM is statistical technique used to manage the activities of the project. And statistics, not statistical, it is statistics. And then the method, the PERT to control time, and the CPM to control cost and time. Because this for production management, and this method for project management. And the progress, PERT research and development project, and the CPM for construction project. Yes, construction project. The time is 3. And in minutes, in this method, we have a project, uncertain tasks in the project, have the consequence, unpredictable activities. In the other side, in CPM, we have the predictable activities, because this is repetitive activities for production management. Production management. Production is activities, cycle activity or repetitive activities. So we can predict activities, every activities, exactly time. And then the appropriate for the PERT for research and development project, and the CPM for research, non-research project. Example, ship building, civil construction, and everything. We use this CPM. From the research and development project, we use the PERT. That is the CPM and PERT. Okay, to graphical analysis from our activity, we can use this, the Gantt chart. The Gantt chart, you have the time in horizontal, that is the time, and you have the activity in vertical axis, like this. That is a Gantt chart. And from this, you know about the duration in every activity. That is the duration, and everything. And from the network, we can chart to this here. This sequence activity like this. The red is sequence activity, because this activity can start before this activity is done. We cannot do this activity or 3 before the activity 1 is done. Okay, so this sequence. And the activity 2, we have the latest time here, and this critical path. So this is critical activity. this completing a project 24 times of the project. So you can represent the network using the concept like here. The concept. The expanded concepts are quite commonly used. They provide an easy graphical representation and when activities might take place using the concept. And the limitation do not clearly indicate detail regarding the progress of activity, do not give a clear indication of interrelationship between the separate activities. Like this, yeah. You cannot see the interrelation of the separate activity in this chart. In another way, we have the CPM and PERT. This is different from the concept. These deficiencies can be eliminated to the large extent by showing interdependency of various activities by means of the connecting arrow called network technique. The connecting arrow for the node to the node or the activity A, B, and we connecting using arrow. So we have the network. You can see the difference from this network in CPM and PERT and compare this, the concept. This simple, I think. How many times we can completing this time? How many times you can see this? That is the time to completing this project. 24 times. But in this chart, you cannot see the connecting from activity 1 and activity 3. You can see this connecting is sequence, I think. Sequence. But how about the activity 4? How the connecting of activity 1 to the 4? You cannot see this connection. You cannot see this connection. But using the CPM or PERT, you know about the connection in every activity. Because over time, CPM and PERT become one technique. Advantages. We have the advantages. Use this technique. We can prediction the relationship. Or prediction. Activity M can start after activity A is done. And this useful for the large project and more efficient rather than the concept, I think. But in another side, we have the limitation of the CPM and PERT. They clearly define independent and stable activities. That is limitation for CPM and PERT. And the specific prediction relationship overemphasizes on critical part. When we can identify the critical part, we can emphasize over this. In industry, you can use the software Primavera, MS Project, Microsoft Project. You can use this to analyze the activity like this. Okay, thank you for this all for this matter for CPM and PERT. And I have the question. You have to answer this question. Completing date. What is completion date? On schedule, within budget, critical activities. What is the critical activities? How can the project can be finished early as the least cost? Can't you? Okay, and this example. Just do this as the task for this lecture. Make using illustration of the network analysis of the mirror design of the product and its associated packaging. For product and packaging, so we can use the CPM. Use the CPM. Why? because this repetitive activity, and we just only we have one time estimation exactly, so you can use the critical path method to analysis and to answer how long will it take to complete this project. How long? This is the question. To answer this question, you can use the CPM method. Okay, just do this task and submit to Spada. Okay. To help you make the network, you have to know about this, the activity number referred to before activity, this activity number, and you know that the activity number must be finished before you can start the activity 3. Activity 2 must be finished before you start the activity 4. Activity 3 must be finished before you start the activity 5. And then activity 4 must be finished before you start the activity 6. And then the activity 5 and 6 must be finished before you start the activity 7. And then the activity 7 must be finished before you can start the activity 8. And then the activity 8 must be finished before you can start the activity 9. And then activity 8 must be finished before you can start the activity 10. And so do this. Activity 9 and 10 must be finished before you can start the activity 11. So that is the sequences of the activity. The information is sequences of the activity. So just use this information about the activity and the completing time, and then the predecessor or the relation of any activity from this information. So you need this information, the activity and completing time, and you need the information of the relation of every activities. Okay, just do well and submit your answer in this part. Thank you very much.